The key to understanding momentum transfer is the understanding of stress tensor. If you know fluid mechanics, you have heard the momentum transfer, but you have no clue about stress tensor, then this video is for you. I'll give you a quick yet commanding overview on stress tensor using simple pictures and animations. Watch until the end and you will be rid of all stress in the learning of stress tensor. The first step to solving all your stress problems is let the stress begin. Suppose we have a fluid with the velocity v, where Ex, Ey, and Ez are the unit vectors in x, y, and z directions respectively. It has three velocity components, Vx, Vy, and Vz. These velocity components respectively carry x momentum, y momentum, and z momentum. Because this is momentum diffusion, each of these momentum components will transfer in all the x, y, and z directions. Now I would like to illustrate momentum transfer using the transfer of x momentum. Suppose a fluid, either liquid or gas, is flowing between two confined boundaries in the x direction only. Unlike in a solid, fluid particles flow in layers, with each layer having a different velocity. Fluid layers at the center flow the fastest, while fluid layers near the solid boundaries flow the slowest. This is due to friction with the inner wall of the solid boundaries. As momentum transfer is from high velocity regions to low velocity regions, the x momentum will be transferred from the center to the wall. If this is a circular tube, momentum will also be transferred to the sides. If the fluid layer is accelerating or decelerating, momentum will also be transferred along the flow direction. I would like to highlight three important facts. First, momentum is transferred in the form of momentum flux, which has the unit of Newton per meter squared. Same with the unit of stress. Because this is momentum diffusion, not convection, the transfer depends on viscosity and velocity gradient. Second, the effects of momentum transfer are the creation of stresses and forces within the flowing fluid. Stresses and forces are actually equivalent, just as stress is normalized force, that is, force normalized by surface area. The transfer of x momentum in x, y, and z directions results in three momentum fluxes, denoted as sigma xx, sigma yx, and sigma cx. Similarly, the transfer of y momentum and z momentum of the fluid in all directions will result in another 6 fluxes. The collection of these 9 momentum fluxes is what we call the stress tensor. The stress tensor is commonly represented in a 3x3 matrix form as shown here. So we have understood that each component of the stress tensor is actually a momentum flux. Now going back to the thumbnail of this video, we can say that step 2, the question mark is actually momentum fluxes, sigma ij. We have a total of 9 momentum fluxes. After we know the step 2, we can now do away with this done loop and chain to a satisfied loop. Momentum flux determines the stress and force within the fluid. The question now is, what controls the momentum flux? Look at this equation 1 closely. The equation shows that there are two important factors, viscosity of the fluid and velocity gradient within the fluid. Note that the relationship is positive, meaning high viscosity, high momentum flux, or high velocity gradient, high momentum flux. Any factor that influences viscosity or velocity gradient would affect the momentum flux. The factors that influence the momentum flux through viscosity are the type of fluid and temperature. The factors that influence the flux through velocity gradient are velocity, system geometry, and surface roughness of the solid boundaries. That's all, how the stress tensor begins. I hope you enjoyed this video. Let me know in the comment section below how much stress you have been relieved of by watching this video. If you don't seem to get rid of any stress in the learning of stress tensor, I suggest you watch my previous video on momentum transfer, or you may subscribe to my channel for more videos. In my next few videos, I will give you more compelling information and insider stories on the stress tensor. Stay tuned, I'm Kyle Tan, and see you in my next video.